Okay, Math 9, here we are, 5.2, like terms and unlike terms. And before you do this lesson video, make sure that you have completed your 5.2 skill builder and all of your 5.1 stuff, quiz, skill builder, practice, lesson, everything like that. So don't start 5.2 until everything has been ticked off beforehand for 5.1 on your front page. Please write down today's learning outcome, again, to demonstrate an understanding of polynomials. So make sure that you're writing that down so that you can cross-reference that with what ends up with your assessment on Jupiter Grades. All right, so moving on. In your book, it says these are all zero pairs. So when they have a dark one, remember that's negative, and a light one, that's positive. That's a zero pair because if you add them together, they add to zero. They cancel each other or they neutralize each other, whichever way you want to think of it. Same with the x's and same with the constants or the ones. Okay, so again with the algebra tiles I was using in last lesson, same thing. A zero pair for x squared, a zero pair for x, and a zero pair for just singular numbers. Okay. So, in the first example here, it says simplify this tile model and write the polynomial that the remaining tiles represent. All right, so what was the whole point of that zero pairs on the last page? Well, if you know that having a positive and a negative tile that's the same adds to zero, they can kind of cancel each other out. So this is the picture in your book. These are the tiles that I'm using again in the SMART lesson. So what I want to do is arrange some tiles so that I can set up zero pairs. So I'm going to move my singles over here, and then I'm going to put this negative x tile closer. Okay? So hopefully you notice that when I move the tiles closer and I put the tiles that are alike, I end up with zero pairs. So look what happens right here. This positive tile and the negative tile end up canceling each other. Or on your picture, these two end up canceling each other. They go away. Same with this positive and negative constant. They cancel each other. Or the same with this. They cancel each other. So it says write the polynomial that the remaining tiles represent. So I still have an x squared. Okay, that's that one. I still have a singular x right here, and it's positive, so I write plus x. That's done. And then I've got these two negative tiles, so I write minus 2. Okay, so simplified, it's x squared plus x minus 2. So what you're going to do now is you are going to pause the video. You're going to try these 3 examples and come back when you're done. All right, so hopefully you've tried these 3 examples. I'm actually writing the answers. I can't click on it, and it's just there. Okay, so write the polynomial that the remaining tiles represent. So first of all, in the first example, what are our remaining tiles? So let's look at what cancels. Okay, this one's going to cancel with this one. That's one. And one of these is going to cancel with one of those. So I'm left with 2 of these positive tiles, these guys, and 1 negative 1. I'm going to color it in dark. Okay, so I end up with 2x minus 1. Hopefully, that's what you put. Okay, and B, which ones are going to cancel? Let's cancel this one with this one. I have none of these dark ones to cancel these light ones, so that's gone. But I can cancel 2 of these dark ones with, let's say, 2 of these light ones. So I'm left with 2 big ones that are dark. I'm left with 3 of the lighter ones, which represent positives. And then I'm left with 2 lighter squares. So these guys represent negative 2x squared. These guys represent positive 3x. And then at the end, plus 2, these guys. Okay, in C, I've got a light one that I can cancel with one of the dark ones. I have a dark one that I can cancel with one of the light ones. And then I've got two lights that can cancel with two darks. So I have a dark, big one. I have three lighter rectangles and two little squares that are dark. So I have negative x squared, positive 3x minus 2. So hopefully that's what you came up with as well in your check. Moving on, at the bottom of that page, and it's your page 188, it says in the booklet, it says that terms can be represented by matching tiles that are called like terms. Okay? So back here, we could cancel these out because they were like terms. We could cancel this with that because they were like terms. It sounds kind of weird because in English you kind of want to say alike terms, but in math we call them like. Okay? So some example of like terms are x squared and negative 2x squared. So it doesn't matter that this one's positive and this one's negative. What matters is that the variable is the same. This is an x squared and this is an x squared. Remember that the coefficient on this one is a 1 and the coefficient on this one is a negative 2. But because the x squareds are the same, they are like terms. 4s and negative s, they both have s's. Okay, and only one of them. 6 and negative 2, they're just digits. They have no variables, so they are like. And 5w and w are like. Unlike terms, an example would be 3s and s squared. I know they both have s's, but this one has 2 and this one only has 1. This one has an exponent of 2 and this one's only 1, so you couldn't group them. 2x and negative 5, this one has an x and this one doesn't. 3d squared and 7, this one has a d squared and this one doesn't. So you can only group like terms. And it says we can simplify a polynomial by adding the coefficients of like terms. So to simplify negative 5x and 2x, all we do is group the coefficients. Negative 5 and 2 makes negative 3. So negative 5x and 2x is negative 3x. Okay, so we are going to simplify these polynomials symbolically, meaning that we are not going to use algebra tiles. We're going to do them mathematically. Okay, so the easiest way to do this is to first of all search through your equation or your expression and identify the terms that are like to start off with. And the way we do that is we start with the ones that have the highest exponent and then we move our way downwards. So use colors, use highlighters, use whatever you want to signify the different terms. So I'm going to start with this one, 3a. And a 6 is not like 3a because it doesn't have an a. But an a is like 3a because it has an a. And the negative 4 is not a like term because it doesn't have an a. So I can group the 3a and the a. I have 3 of them and I have them another. So I have 4a. And then they're done. And then I've got this 6 and negative 4. I can group them because they're just numbers. 6 and negative 4 is 2. Okay, second question. Again, I want you to group them according to highest exponent to lowest exponent. So I'm going to start with the x squareds. Negative x squared and 3x squared are like terms. So when I group a negative x squared and a 3x squared, it's like a negative 1 and a 3. I have 2 x squareds. Okay, next. So this is when you could maybe get out a different color highlighter. Now I'm going to group the x's. So this x can be grouped with this x. Okay, so I have 4x and I have negative 4x. They actually add to 0. So I'm not going to write anything. I wouldn't write 0x. Last is negative 5 and the 1. Negative 5 and 1 is negative 4. Okay, so move on to your check. Pause the video here. And then when you are ready, come back and see if you got them right. Okay, so welcome back to the check, and hopefully you tried these questions yourself before going through this. Okay, so start with the first example. I think I whited out on your page all of these leading things. So give me a second. I'm going to do it here. I'll pause and I'll come back 1 sec. All right, so I got rid of those annoying, leading, helpful things that we don't like. Okay, so let's go through. I'm going to get out my highlighter. All right, so simplify each polynomial. I'll group D's. So if I have a 3D, sorry, if I have a 5D and a 3D, I have 8D. And then I'll group what's left over. 2 minus 1 is 1. All right, B, I've got A squareds and I have A. So let's start with the highlighter. A squareds with other A squareds. A's with other A's. Those are the ones that I can group together as like terms. So if I have 2A squared and 5A squared, I have 7A squared. I have negative 3, but positive 7A. I end up with 4A. Next question. X squareds with other X squareds. X's with other X's. And then just plain old numbers with numbers. So negative x squared and 2x squared, it's like a negative 1 and a 2, so it's x squared. I wouldn't write 1x squared, but it's not wrong. The x's, I have a 4x and then just a singular x, so I have 5, because 4 plus 1 makes 5. Just numbers, I have a negative 5 and a positive 3. Negative 5 minus 3 is negative 2. Okay, last one, highlighter. X squareds with other x squareds. X's with other x's, and then just numbers with numbers. So 2x squared and negative 2x squared, oh, they add to 0. They're done. Don't have to do anything with them. I don't write anything down. It adds to 0. 6x and 7x, 13x, 7 minus 11, negative 4. So hopefully that check for you went okay and you're getting the hang of this stuff. Okay? So that's the end of section 5.2. You need to move on to your practice. Come and ask questions as needed. Replay any of the video parts that you may need to watch again. Okay? So your list to do. You need to make sure that your 5.2 skill builder is done. Work on your 5.2 practice. Do that online quiz. Hey, don't forget you need to be working on your learning journal as we go. And you've got that unit problem, that 100 chart that's in your textbook. So make sure you're having a look at that and you're keeping up with that. And I would like that submitted on Jupiter Grades as a PDF file. So if you have questions about that, how you do that, you need to come and see me. All right, good luck on section 5.2.